solar system which we have today looks pretty stable, with the planets revolving around the sun from thousands of years. And this system, with sun at the center and these perfectly crafted orbits of the planet, is bound together by gravity. Now, gravity is just a force acting between any two bodies, and the strength of this force is directly proportional to the product of the masses of these two bodies, and it's inversely proportional to the square of the distance between them. And even though the amount of this force applied on both the bodies is equal, due to Sun being much more massive than all the planets put together, the effect of this force on Sun is almost negligible. And that is why, for understanding's purpose, we could think of gravity as a pull from the Sun on all the other planets. Now, without this pull, the planets will go into straight lines, as per Newton's law of inertia, which states that any body in motion will continue to be in motion in the same direction with the same speed until unless an external force is acted upon it. So, to put these planets which are traveling in a straight line into an orbit, just the right amount of gravity is required. And by the way, Jupiter is the only planet in our solar system massive enough to make the sun wobble in its place. And in fact, if we simulate a solar system with Jupiter being 1000x more massive, the sun will not stay in the center anymore, and these two will orbit around each other, and all the orbits of the external planet will just disrupt. Why are we so sure that the solar system is stable? In fact, the dynamics of solar system is very complicated. It has 8 planets, and each one of them is exerting this periodic gravitational pull on each other. And the question becomes that whether the net effect of this periodic gravitational pull averages out to zero over a long time, which means that these planets will continue to follow orbits similar to the ones they have today, or whether these small mutual interactions between the gravitational pulls of these planets gradually degrade the regular arrangement of these orbits and will eventually lead to the collision of two planets or ejection of some planet into the interstellar space. Now, we should also remember that this interplanetary gravitational pull is very small. For example, the pull on Earth from Jupiter, the largest planet in the solar system, is just 10 per million of the force from Sun. But the time available for their effects to accumulate is even longer, about 4.5 billion years from the birth of the solar system to another 8 billion years till the death of the Sun. The answer to this question could be found by simulating the orbits of these planets for a few billion years on our computers by the researchers. And for that, they needed to know the exact masses of these planets and their current orbits, which they already knew with great accuracy. And they also needed to incorporate the external forces on these planets by the stars or the comets or asteroids or satellites, etc. And with all of that, they also needed a numerical method which is good enough to calculate these motions for a few billion years with great accuracy. And with all of that in place, when the simulations were done, it was found that for a few billion years from now, until the sun dies and swallows all the inner planets, the planets were still in a stable orbit like they are today. So, in that limited sense, the solar system is stable. However, it is to be noted that the calculations done with slightly different parameters, like different initial positions, but within the range which are allowed by current observations, resulted into a change in the simulation at an alarming rate. Now, this implies that for practical purposes, the positions of the planets are unpredictable further than about 100 million years in the future because of their extreme sensitivity to the initial conditions. And in about 1% of these simulations, Mercury's orbit becomes sufficiently eccentric so that it collides with Venus before the death of the Sun. Thus, the answer to the question of the stability of the solar system, or more precisely, will all the planets be there when the Sun dies, is not yes or no. It is yes, but with 99% probability. And there are two things to be noted here. One is that the time required to lose Mercury is about similar to the time which has passed since the birth of the solar system, and the fact that there are places in our solar system where a new planet could be inserted without causing immediate instability. So, both of these facts could be explained naturally by imagining that the solar system started with more planets than it has today, in a configuration which was unstable in timescales smaller than its current age. And as the time passed, the system lost more and more planets and thereby gradually self organized itself into a more and more stable state. And if given enough time, it will continue to change its state just like it did in the past. The truth is that in the universe as we know it, there is nothing stable. Everything is impacting everything and things are changing, just that the time scales are too large for us to comprehend that things feel stable to us.